All right, away we go. We now have a absolute value function right here. And then just a reminder once again, okay, absolute value functions are a V-shaped function. And also a reminder that you can get started with any of these graphs by doing a mapping notation first. All right, and that's old news, so I'm just going to breeze through that. Key point at 0, 0. So we plug in 0, 0 into the mapping, and you end up with 4, negative 3, which is the key point. Okay, no need to do any other key points. Okay, we just want a rough sketch of the graph is all that's necessary. So we could get started already. Okay, we have 4, negative 3, so we can put that point in right here. And then we want to look to see, are there any reflections? So look in your mapping notation, and the x and the y are both positive. So it's going to be a turn up graph. Again, I don't really know what this is going to look like. It may be spread out more. It might be a little skinnier graph. We're going to find out when we get the x-intercepts and the y-intercepts and all that. We could write the domain and range at this point though. Okay, domains are all real numbers, much like with parabolas for every example. And in this case, okay, we have a minimum y value of negative 3, but then goes to infinity, and then that is our domain and range. Okay, so we have now we are going to work on y-intercept and x-intercept. So the y-intercept first would mean x is equal to 0. So if I plug in a 0 for x, I have to do the order of operations for this. So I do the inside brackets, or the absolute value, and then remind yourself that the absolute value of a negative number is the positive version of that number. So absolute value of negative 4 is positive 4. And a half times a 4 is 2, and that's going to bring us to negative 1. And we now have our y-intercept. My graph doesn't show a y-intercept of negative 1. So this is a great opportunity for me to kind of just switch up my graph a little bit. It's still going to have that same key point and the same general shape, but now I know that it's going to pass through negative 1, so it's going to be a much wider graph. And the reason for that is because if you look at the vertical stretch, it's a half. All right. Okay, let's take a look at getting the x-intercepts here, which is going to be some algebra. So once again, okay, we're just going to ignore this for the time being. And right here, okay, we're going to put in our equation, which I will double check. Note that was a negative 3. No announcements yet, that's good. And away we go. Okay, let's get the x-intercept, which is plug in 0 for y. And according to our graph, it looks like there will be 2 x-intercepts. Okay, let's do this. So let's put in a 0 for y. And then you want to isolate the x. So I'm going to bring the minus 3 over to make it a positive 3. Now, how do I get rid of that 1/2 in front? I can times both sides of this equation by the reciprocal of 2. So 3 times 2 is 6. A half times 2 is 1. So really nothing in front. Or you can think about it as dividing both sides by a half, which is really multiplying by 2. That works as well. And at this point, okay, this is going to be a review of some grade 11 math right here. So we break apart this into 2 cases. We do either the positive version of 6 or the negative version of 6. Hopefully you guys remember how to do this from grade 11. But if not, it's something you can catch on to very quickly. And here we get an x-intercept of 10. And here we get an x-intercept of negative 2. And then that would be our 2 x-intercepts right there. And we can go back to our graph and we can fine tune that. Okay, that's a minus 2, 5, 6, 7, 8, 9, 10 right there. Sure, that's a 10. Those are the x-intercepts. And if you choose to, you can go up to, or you go over to Desmos. So many emails and announcements, but look at me multitasking here. That's good. Let's take a look at this graph right here. And this is what we were looking at right here. You can click on the X and Y intercepts to see if you got those right. And you can see the graph looks good. I think we're good. Let's move on to the third example in another video.